Okay, so this time we're going to predict where the reaction is going. Okay, usually chemical reactions proceed to the side in which there are no present substances. That means if you do not have any products, the reaction will proceed from reactants to the product side. If you do not have any reactants, your reaction will proceed from products to the reactant. Okay, so that's why the direction of the reaction always proceed to the side with no amounts of substances. Okay, however, the problem is that what if both sides of the equation have certain amounts of substances? Let's say for the reactant side we have this concentration, the product side we have this concentration. What do we do next? Okay, so in order for us to answer where the reaction is going to, we have to use another equilibrium constant expression, which is called the reaction quotient Q. Okay, so what we're going to do is that we should be given with K value. Here, this is given. We are going to solve for this, and we are going to compare the value of K and Q. As you can see also, K and Q have the similar structure. This is the concentration of product raised to their coefficients, concentration of products raised to their coefficients, reactants, and coefficients. So that means K and Q are similar. However, there's the subscript I. So the subscript I tells you that the concentration is in the initial state. Okay, so that means all the concentrations in Q should be the initial concentration. However, in K, as you can recall the previous problems we answered, all the concentrations are in equilibrium. Okay, so that is the only difference. For K, all the concentrations are already in equilibrium. For Q, all the concentrations are the initial amounts. Okay, so once we're able to solve for the Q and K, we are going to compare them so that we'll be able to know where the reaction is going, whether to the reactant side, the product side, or there's no direction at all because they are the same. Okay, so if we have this number lines here, so we have three number lines here. The gray circle is the equilibrium constant. That is where your reaction should go. Reaction should go towards equilibrium. Okay, so this is the Q, the orange circles. Okay, and that is our initial state. Okay, if it happens that your Q is less than K, that means the ratio of the concentration of your substances is less than what it should have or what it should be. That means the reaction should pop up with that. That means the reaction will proceed towards the product side. Okay, so I will indicate that as a right an arrow pointing to the right side. Okay, whenever I write an arrow towards the right side, it means the reaction is going to the product side. Okay, there's one way to remember that. Okay, the reaction is going to the product side or towards the right side, because on the right side you will find K. If your Q is equal to K, so that means they're already in equilibrium, so nothing to worry at all. Okay, it's because there's nothing to do anymore. Okay, if your Q is greater than K, that means the concentration of your substances initially, or the ratio of their concentrations, is way greater than what should they have. That means the reaction should go back When I say go back, it will go back to the reactant side. The reaction will point to the left or going to the reactant side. Okay. So for you to remember the directions of the reaction, it will be easier for you to write a number line and write down some arrows when comparing Q and K. So if Q is less than K, you write the right hand arrow. That means the reaction is pointing towards the product side. If your arrow is pointing to the left, that means the reaction is going to the reactant side. However, if they are on the same spot, there's nothing to do anymore because the system is already in equilibrium. Okay, so let's try this problem. And so let's have this. At the start of the reaction, there are 3.51 moles of nitrogen gas, 3.67 times 10 raised to negative 2 moles of H2, and 7.51 times 10 raised to negative 4 moles of NH3 in a 3.75 liter reaction vessel at 375 degrees Celsius. If the equilibrium constant is 1.2, predict the net reaction at equilibrium. That means we are going to ask where is the reaction going. Okay. So to do that, in order for us to predict the direction of reaction, we are going to compare KC and QC. Okay, so we're going to compare this by the reaction quotient. Okay, so since K is already given, we are going to solve for QC. Okay, so we have the reaction. Let's write the QC. QC is equals to the initial concentration of ammonia squared divided by the initial concentration of N2 times the initial concentration of H2 cubed. Okay, so let's go back in the problem. The problem gives us the idea of the amount of the substance but in mole units. Okay, so what we need is molar concentrations, not moles. So in order for us to solve for the number of in order for us to solve for the concentration of their substances, what we're going to do is that we will divide the moles of our substance by the volume already given. Okay, so that means to solve for the initial concentration of NH3, that is the moles of NH3, that is 7.51 10 raised to negative 4 mole divided by 3.75 liters to get the initial concentration of H2, that is equal to 3.67 times 10 raised to negative 2 moles divided by 3.75 liters to get the concentration of N2, that is 0.351 moles divided by 3.75 liters. Okay, so then we're going to solve for that. So okay, so for NH3, the initial concentration is 2.0 times 10 raised to negative 4 molar. For H2, that is 9 point what's that 9.8 times 10 raised to negative 3. For N2, it is 0.0936. So I'm going to copy all the digits. Okay, so anyway, So the following are our initial concentrations. So after solving for the initial concentrations, what's next is that we're going to solve for the QC. Okay, so QC is then equal to concentration of NH3 plus 2 times 10 raised to negative 4 square over the concentration of N2, 0.0936 times the concentration of H2 times 10 raised to negative 3 cube. So I'm going to solve for that. So okay, so QC is equals to 0.454. Okay, so after solving for Q, we're going to compare it with with the KC. Okay, so we're going to write a number line. In the middle, we will write K, which is equals to 1.2. And since QC is here, okay, so as you can see, your Q is less than the K value, so the reaction should go to the right side, or that means the reaction will proceed to form the products. Okay, so that's the idea. You solve for the QC, you compare the value of QC with KC, then write an arrow towards the K. So in this case, the arrow is pointing to the right side, so that means the reaction is going to the right side or towards the product side. If your arrow is pointing to the left, that means your reaction is pointing towards the reactant side. Okay, so that is how you solve for direction problems.